In the quiet dance of flickering flames lies the story of one of nature's most captivating processes, combustion. From the humblest of campfires to the roaring engines of industry, combustion shapes our world in ways both seen and unseen. But what exactly is combustion? And what secrets does it hold within its fiery embrace? To uncover the science behind this phenomenon, we must delve into the heart of chemistry. Combustion is a chemical reaction where a fuel combines with oxygen gas to produce heat, light, and often, other products like water and carbon dioxide. At its core, combustion involves the rapid oxidation of fuel molecules. When a fuel molecule encounters oxygen molecules, and sufficient heat, it breaks apart, releasing energy stored in its chemical bonds. This process typically involves three key components: fuel, oxygen, and heat. Without any of these elements, combustion cannot occur. Fuels come in many forms, from natural sources like wood and coal, to refined products such as gasoline and natural gas. Each fuel has its own unique chemical composition, influencing the characteristics of the combustion reaction. Enough heat is needed to break the initial bonds in the fuel, triggering a chain reaction. This chain reaction allows the fire to spread and grow. Removing heat, like with the water spray, disrupts the chain reaction and extinguishes the fire. In the lab, we can recreate combustion reactions under controlled conditions to study their properties and behavior. By carefully measuring variables like temperature and reaction rates, we gain insights into the underlying chemistry. During combustion, the reaction progresses through several stages. It begins with ignition, where a spark or heat source initiates the reaction. Next comes propagation, as the reaction spreads through the fuel, releasing energy in the form of heat and light. Finally, the reaction reaches completion, producing the final products. By controlling the fuel, oxygen, and temperature, we can manipulate fire for a variety of purposes. The spectacular colors of fireworks come from adding metal salts to the fuel. These salts get excited by the heat and emit light at specific wavelengths, creating the beautiful display. From the warmth of a campfire to awe-inspiring fireworks, fire continues to be a force of fascination and wonder. Understanding the science behind combustion allows us to not only respect its power but also harness its potential for countless applications.